Hello everyone, this is Aditya from ACE Academy. In this video, let us look at Civil Engineering GATE 2021 Mathematics questions. Now from both set 1 and set 2, there were 9 questions each. 5 1-mark questions, 4 2-mark questions. Let us look at their solutions. So this is the first question. He says, vehicular arrival at an isolated intersection follows Poisson distribution. We know the number of vehicles arriving in a particular duration follows Poisson distribution. He also gives the mean arrival rate, right? Mean arrival rate is given. How much is the mean arrival rate? 2 vehicles per minute. That means on an average, there are 2 vehicles arriving per minute. The probability that at least 2 vehicles will arrive in any given 1 minute interval is. It clearly says what's the probability that at least 2 vehicles. What do you mean by at least 2 vehicles? Now when you say at least 2 vehicles, it is 2 or more than 2 vehicles arriving in that duration. It's a direct problem. Let us look at the given data. Have a look at this. So what I have done is I have written the mean arrival rate, that is 2 vehicles per minute. So I have assumed that as lambda. Next, let x represent the number of arrivals. Let x represent number of arrivals. We know that x is a Poisson random variable. So if x is a Poisson random variable, by now you should be aware of what would be its probability mass function. So have a look at that. But what is asked is this: what's the probability that x is greater than or equal to 2? So he says at least 2 vehicles. So that's why I say I have written probability of x greater than or equal to 2. Usually probability of x greater than or equal to 2 means you would be tempted to write probability that x equal to 2 plus probability that x equal to 3 plus probability that x equal to 4 and so on. That means you are supposed to add many number of terms. Instead, if you can work with the complement rule, then this is going to be a very simple approach. What do you mean by complement rule? You can say this particular probability is same as 1 minus probability that x is less than 2. Now when you say probability that x is less than 2, you are supposed to cover probability that x equal to 0, probability that x equal to 1. So right, so this is very easy to find. That's what is written here. If you can substitute what is probability that x equal to 0, probability that x equal to 1, we are done with this question. So let's look at that. So here I have mentioned the probability mass function for you. So if you have the mean arrival rate, then the probability that the random variable x takes a particular value called small x is given by e power minus lambda power x by x factorial, where the possible values of x are 0, 1, 2 and so on. What we need is probability that x equal to 0, probability that x equal to 1. Simply substitute x equal to 0, x equal to 1, take their probabilities, put it here, and then do the simplification. Use your calculator, virtual calculator, get the answer. So the answer turns out to be 0.59. So it's a very simple problem that was asked in the GATE. Let us look at another question. Now he says, consider this limit. Limit x tends to 1, 1 by log x minus 1 by x minus 1. So let's directly substitute this limit. So 1 by log x, 1 by log 1. Log 1 is 0. So 1 by 0 is like infinity. Now you take this limit, put it here. Now you again get 1 by 0. 1 by 0 is infinity. So what you get is infinity minus infinity. Infinity minus infinity is an indeterminate form. Whenever you come across an indeterminate form other than 0 by 0, infinity by infinity, what we usually do is convert or reduce that indeterminate form either to 0 by 0 or infinity by infinity. So what we are supposed to do is convert this to infinity by infinity or 0 by 0 form, and then apply the well-known result, that is L'Hospital rule. Let's look at this. That means even this problem is going to be very simple. Have a look at this. Like I said, we have infinity minus infinity. So now I'm going to reduce that either to 0 by 0 or infinity by infinity. So what I have done is I have cross multiplied, taken the LCM. So this is what I get. Now when I substitute the limit, so I have 1 minus 1 here and log 1 here. 1 minus 1 is 0, log 1 is also 0. In the numerator I have 0. In the denominator you have 0 here. Log 1 is again 0. So finally you see a 0 by 0 form. Apply L'Hospital rule. So what you are supposed to do is take the derivative of the numerator, derivative of the denominator, and then put the limit. Right? So let us look at that. So you can see here I have taken the derivative of the numerator. For example, what's the derivative of this x? The derivative of x is 1. The derivative of 1 is 0 because the derivative of a constant is 0. Log x derivative is 1 by x. Like that, here it looks as if it's a product rule. So take the derivative of this into this plus derivative of this into this. So I have done all such calculations in the next page. So have a look at these calculations. So this is what I get. Now you can put the limit. Let's see what happens when I put the limit. When I put the limit, so I have 1 by 1. So 1 minus 1 is again 0. So here also I have 1 minus 1 which is 0. Log 1 is also 0. That means again I get 0 by 0 form. Whenever you again get that 0 by 0 form, you can actually apply L'Hospital rule once more. So let's apply L'Hospital rule. The derivative of 1 is 0. The derivative of 1 by x is minus 1 by x square. So the minus minus cancels. What you have in the numerator is 1 by x square. Denominator, again you can see that. So in the denominator, this is again like a product rule. So take the derivative of this, and then apply the limit, right? So the derivative, so it's like I have taken this as u and this as v. So this is something like u by v. You can even take uv also form, but it doesn't matter, same answer you get. So when I take the derivative of this, it's something like when you have u by v, it is v into derivative of u minus u into derivative of v by v square. So that's what is written here. And as usual, log x derivative is 1 by x. Now you try to put the limit. In the numerator, what do I have? I have 1 by x square. In the denominator, what do we have? When I put 1 here, this is gone. Now I have x by x square. Again, that is 1. 1 plus 1. Because 1 by 1 is 1, now 1 plus 1 is 2. In the numerator, you have 1. So finally, what you have is 1 by 2. So the answer for this question is 1 by 2. Right? It is just application of L'Hospital rule multiple times. Right? Not only this year, many, in the past as well, this kind of questions have been repeated. Let's see next question. Have a look at this. It's a very simple problem. He's asking you the rank of the matrix. What we are supposed to do is reduce this matrix to row echelon form. Once the matrix is reduced to row echelon form, you just have to count the number of non-zero rows. Let's reduce that to row echelon form. So see that here you have got the element 1. Use this, make this, and this 0, and then follow the same procedure for the other rows and then reduce that to row echelon form. Let us look at its solution. So have a look at this. So in the first step, what I have done is, so you can see this clearly, there is 3 here. So I say R1, using R1, I want to make this particular element 0. Using R1, I want to make this element 0, this element. So how do you make that? So I'll say R2 is simply R2 minus 3R1. Look at R3. R3 is R3 minus 5R1. Look at R4. R4 is R4 minus 7R1. So do these steps, write all the values properly. Right? So look at this, I have done this calculation. You can also do it. Observe now that there is minus 2 here, minus 4 here, minus 6 here. Using this element, you are supposed to make this and this as 0. Right? Using this element, make this and this as 0. One interesting observation is, if you are really clever, here itself you can comment about the answer. The gate exam is about this. GATE exam is not about solving it in detail. GATE exam is about solving the question in an elegant way, right? So what do you mean by that elegant way? Elegant way is something like this. Now I see that row 3 and row 4, right? Row 3 is something like twice row 2. Row 4 is like 3 times row 2. So what I can do is, using row 2, I can completely make the row 3 0. Using row 2, I can completely make row 4 0. In that case, how many non-zero rows you will have? You will have two non-zero rows. What are they? First row and the second row. And the remaining two rows are 0. Now in such case, the matrix would be in row echelon form. You just have to count the number of non-zero rows, which is 2. The rank of this matrix is 2. Another question, right? Now, after looking at this, you will feel that for sure you are going to score 13 marks from this mathematics topic. It is going to play a huge role, each and every mark, even a 0.1 mark is also going to play a crucial role. Let us look at this. He says the values of abscissa and ordinate of a curve are as follows. So he gave the x and y coordinates. So what is he asking? Using Simpson's 1/3 rule, what is area under the curve? Let me count the points. 1, 2, 3, 4, 5. 5 points are given. Imagine if 2 points were given, right? Then you will have one subinterval. Imagine 3 points given to you. If 3 points were given to you, then you will have 2 subintervals. Like that, 5 points are given, so you will have 4 subintervals, right? Simpson's rule works when the number of subintervals is an even number. So it's okay. Now you can proceed. If you are aware of Simpson's rule formula, then it's a direct problem. So what is Simpson's rule formula? How many subintervals I have? I have 4 subintervals. So the Simpson's rule is something like h by 3, y0 plus y4, because there are 4 subintervals. Y0 plus y4 plus 4 times y1 plus y3 plus 2 times y2. If you can identify what are y0, y1, y2, y3, y4, we are done with the problem. So let's have a look at Simpson's 1/3 rule. So area under the curve using Simpson's rule is given by this formula, like I said before. H by 3, y0 plus y4, 4 times y1 plus y3, twice y2. Now substitute the ordinates. So this is like y0, y1, y2, y3, y4. Substitute. Use your virtual calculator. It is just a matter of addition, multiplication, right? You can see that in the GATE exam, right? So you are entering, or you are applying for master's admission, and then this is a matter of what? Multiplication and addition. So if you have got this what do we say, this attitude, then you are going to score it easily. So now the final answer is 20.67. Do the mathematics, use your virtual calculator. So we are done with this problem as well, which was asked on Simpson's 1/3 rule. Let's look at another question. The shape of the cumulative distribution function of Gaussian distribution is dash. There are options given like bell-shaped, S-shaped, horizontal line, straight line at 45 degrees. Most of the students, what they do is, whenever this Gaussian distribution comes into their mind, they feel that, or they get something like a bell-shaped curve, right? Most of the time, whenever we talk about a Gaussian random variable, they get an idea of a bell-shaped curve. Here, you should have a clear idea of what is a probability density function, what is a cumulative distribution function. The probability density function has a bell shape, whereas the cumulative distribution function shape is different. Let's have a look at that. That means if you have got that basic idea, you are going to score here. Let's have a look at what's the shape of the probability density function. The probability density function, PDF stands for probability density function, so which has got the bell shape. It's a bell shape. Now the discussion is not about the probability density function. The discussion is about cumulative distribution function. What is the definition of cumulative distribution function? This is the definition of cumulative distribution function. Capital F of x is the probability that x is less than or equal to a particular value called small x. That means you will be finding, let's say if I say x as 1, you will integrate this density function from minus infinity to 1. So whatever area you get, that would be capital F of 1. For example, if I ask you what is capital F of minus 1, then you are supposed to integrate from minus infinity to minus 1. Whatever area you get, that is your capital F of minus 1. Like that, you have to find each and every value, then you get this capital F of x. So this capital F of x has got S shape, right? Most of the students, what they do is, whenever Gaussian distribution comes, immediately this bell shape comes into their mind, right? So if you have got the basic idea, then you can answer this easily. Let's look at another question. The volume determined from this triple integral, he also gives you the boundaries for this v will be dash. Okay, have a look at the following observations. X is raised to 1, y is raised to 1, z is raised to 1, right? Now when x is raised to 1, y is raised to 1, z is raised to 1, then it's a easy problem, because what people will feel is, sir, he says 2, 3, 1, 2, 0, 1, right? What are the limits of x, limits of y, limits of z? In this particular problem, what you can do is, you can assume the limits of x to be anything, limits of y to be anything, limits of z to be anything. Usually what happens is, the first boundary that they gave will be the limits of x. This will be the limits of y, this will be the limits of z. Suppose if x was raised to 3, y was raised to 2, z was raised to 1, now in that case, limits or the order of integration matters. But here x is raised to 1, y is raised to 1, z is raised to 1. So you can take any of them as x, y and z limits. Let's look at the detailed solution. Have a look at this. What I have done is, I have taken limits of x to be 2 to 3, limits of y as 1 to 2, z limits as 0 to 1, and the function that you have is 8 xyz dx dy dz. See, it's a very simple problem. Usually what happens is, suppose if it was given x power 3, y power 2, z power 1, now the limits will also be given in a different way. For example, it would be given this way. X limits will be in terms of y and z. X limits will be in terms of y and z. Y limit will be in terms of z. Z limit would be something like a to b. In such case, the first integration would be with respect to x. Now when you do it with respect to x, you have to treat y and z as constant. But here, you don't have that particular setting. What you have is x limits from 2 to 3, y from 1 to 2, z from 0 to 1. In such case, what you can do is, you can split the integrals, right? That's what I've done. I've put 8 out. Integral 0 to 1 z dz, integral 1 to 2 y dy, integral 2 to 3 x dx. Do the integration, substitute the limits. It's a matter of simple integration. Now again, it's an all India exam, and look at the question. If you have got basics, it's simple matter of simple integration. So the answer for this is 15. Let's look at another question. The solution of the second order differential equation with boundary conditions is dash. The first observation is, I look at the differential equation. The right side you have 0. The right side you have 0. It's a homogeneous differential equation. Its complete solution is simply the complementary function. You need not find any particular integral in this problem. And after that, you have to use this conditions, that is the boundary conditions, and then find the values of the constants. So the first thing would be write the auxiliary equation, find the roots of the auxiliary equation. Looking at the roots of the auxiliary equation, comment about the complementary function. That's what we are going to do now. Look at this. I have rewritten the differential equation, and then I'm looking at the roots of the auxiliary equation. Look at the polynomial d square plus 2d plus 1. D square plus 2d plus 1 can be written as d plus 1 whole square. That means the roots are minus 1 comma minus 1. The nature of the roots is real and equal. When the roots are real and equal, the corresponding complementary function is c1 plus c2x into e power minus x. That's what is written there. Now, this is not just the complementary function. This is our complete solution as well, because you are working with a homogeneous differential equation. So, our interest is now to find the values of C1 and C2. So let us look at the values of C1 and C2. So this is my complete solution, and the boundary conditions, that is y of 0 is 1, y of 1 is 3. What do you mean by y of 0 equal to 1? Y of 0 equal to 1 means when x is 0, the value of y is 1. So use that. When x is 0, that means 0 here, e power 0 is 1. So what you get is C1 equal to 1. Put this aside. What does this mean? Y of 1 equal to 3. It means when x is 1, the value of y is 3. Put that. So 3 here, 1 plus C2 into e power minus 1. Do the simplification, get the value for C2. Now you have got C2 as well as C1. So the final answer would be 1 plus C2, that is 3e minus 1 into x whole multiplied with e power minus x. Let's look at the options. So I see that there is an option like this, e power x plus 3 minus 1 into x into e power minus x. So that is option B. It's a very simple problem. Let's look at another question. This year, interestingly, there were 2 questions from numerical integration. So what is this question about? He gave an integral to find using which rule? Trapezoidal rule. So how many subintervals? 4 subintervals are given to us, and the limits are from 0 to 1. Again, it's a very simple question. There is no traps here. Very simple, direct formula. So what you can do is you can prepare the table. So what kind of table you can prepare is you can prepare x, y. You make sure that you get 4 subintervals. To get 4 subintervals, we need 5 points, right? So have a look at this table. So 0, I need 4 subintervals now. So 0, 0.25, 0.5, 0.75, 1. Between these 2 points, I've got 1 subinterval. Between this, I've got 1 subinterval. Between this 1, between this 1. So 4 subintervals. What is the function that he gave? He gave e power x. So now, what's the value of e power x when x is 0? E power 0, 1. What's the value of e power x when x is 0.25? E power 0.25. So you have to use your virtual calculator, find the value, right? I have already done it for you. E power 0.5. So this is e power 0.25, e power 0.5, e power 0.75, e power 1. Once you have got all these values, you know the trapezoidal rule formula, which is h by 2 into y0 plus y4, because he said 4 subintervals, na? Y0 plus y4 plus twice the remaining values. That's what is written here. So yeah, I have written it here, trapezoidal rule. Right, this value is approximately equal to what? H by 2, y0 plus y4 plus twice the remaining values. You have got all the y values, put that here and get the answer. So for this you have to use the virtual calculator. So after simplification, what you will get is 1.727. So we have that in the options as well, which is option. Let's look at the next problem. In this is even a 10th class student, 9th class student can solve this. What is given is P and Q. they are asking you to find Q transpose into P transpose. So what we do is first find Q transpose, find P transpose, do the matrix multiplication, right? So this is not even the 10th standard. That means what I want to say is gate exam, in the gate exam there are certain there are certain questions which are very simple. If you are a clever student, you will first solve those questions and then go for the difficult ones. Let's solve this. I'll first find Q transpose and then P transpose. I'll then multiply. You know the meaning of transpose? Transpose means, suppose if this is Q, this is a row, write these elements of a row as elements of a column. This is again a row, take this row, write this as elements of a column. That's what is done here. I have taken this, I have written this way. I have taken this, I have written this way. So I'm done with Q transpose. You also write P transpose. So this is a row, write it as 1, 2, 3, 4, write it as 3, 4 here. Now after that, do the matrix multiplication. Row times column. This into this into this, and so on. For example, this into this is 0 plus 1 into 2 is 2. That's what is there. 0 into 3 plus 1 into 4, which is 4. Do this complete this matrix and you see that the answer is 2, 4, 1, 3. So again, it's a very simple problem. 2, 4, 1, 3, 2, 4, 1, 3. So this is the answer for this question.